Good evening, students. Welcome back to mathematics class. So today we'll discuss some multiple choice question. That question will already be posted in the WhatsApp group. So discuss those questions. Before that, actually we left out one question. That is the third question, right? So small, that is in calculation, sin theta into sin theta or sin square theta. So that small error was there. So we'll complete that question. And as soon as I complete the class, posted in that sin theta and sin theta or sin square theta, right? So I have written sin theta over there. That's why. So that answer was not able to get in that one. So we will complete that question. And very good for that, sin and sin theta or sin square theta. Sin square theta it is. Okay, this is determinant of A, right? So let A is equal to 1 sin theta 1 minus sin theta 1 sin theta minus 1 sin 1, and where theta lies from? Theta lies from 0 to 2 pi. Then what is the value of determinant of A? Determinant of A. If we calculate determinant of A, right? Sin is plus minus plus 1 into suppressing its row, its column, right? 1 into 1 is odd, 1 minus of minus plus, right? So sin theta and sin is odd, sin square theta it is, right? So in yesterday's class I wrote sin theta, right? So it is sin square theta. 1 plus sin square theta, next minus sin theta into suppressing first row, second column, right? First, second column, 1 into minus theta, 1 into minus theta minus sin theta plus sin theta minus sin theta plus sin theta plus 1 into suppressing first row, third column, minus of minus plus sin theta and sin theta, sin square theta plus 1. So this is anyhow 0 minus sin theta plus is what? 0. So 1 plus sin square theta and 1 plus sin square theta, that is 1 times of 1 plus sin square theta plus 1 times of 1 plus sin square theta, 2 times of 1 plus sin square theta. So determinant of A is 2 times of 1 plus sin square theta. And where does theta lies from? 0 to 2 pi. Since theta lies from 0 to 2 pi. So between this interval, sin can take which value, right? So range of sin is what? Minus 1 to plus 1. So from 0 to pi, it can take the value from minus 1 to plus 1, right? Sin theta can be taking the values from minus 1 to plus 1. So if I go for squaring on both sides, right? I was taking the square, or is sin theta lies from minus 1 to plus 1. What is square of sin theta lies from? So square of any number is not a negative. So square of, right, sin square theta lies from 0 to 1 because square of any number is not a negative. So minimum value if we take, right, what is sin square theta minimum value? 0 and maximum are plus 1. If I take minimum value as 0, right, one is sin 0, sin of 90 degree. 90 degree comes in this interval. And one is sin is sin 90 is equal to what? 1. Sin 0 equal to what? 0. So sin square theta minimum value is 0 and maximum is what? 1. So sin theta is 0 when theta equal to 0 and sin theta equal to 1 when theta equal to 90 degree. So if I take minimum as 0, right? So minimum value equal to minimum value is equal to what? 0 if I take. So determinant of A, right? So sin 0 is what? 0. So 1 plus 0 equal to what? 1, 1 into 2, 2. So minimum when I take theta equal to, or else when I take theta equal to 0, sin theta equal to 0, this is your minimum value, right? And when I take theta equal to what? Pi by 2, sin 90 degree, what is sin 90 degree? 1. I am getting maximum value. So minimum value of square is 0, maximum is what? Plus 1. So sin 90 equal to what? 1, 1 plus 1 is equal to 2 2 is 4. So determinant of A equal to what? 4. This is your maximum value. So that indicates determinant of A belongs to the interval 2 to 4. So minimum value is 2 and maximum is what? 4. For what? Determinant of A. Right? So this value lies from 2 to 4. Which option is correct over there? That is your fourth option is correct. So determinant of A belongs in the interval 2 to 4, or else sin square minimum is 0. If I take 0, 1 plus 0 is 0. 2 will get a minimum, maximum is plus 1, 1 plus 1 is 2, 2 2 is 4, maximum is 4. So this was about the yesterday's class question. So now we'll discuss that discussion paper. So 25 questions are there. So let us say how much question we can discuss so that it will be useful for your next coming weekly test, which is on Sunday. And already syllabus is what exercise from 4.2 to 4.6 it is, right? So first question, let us discuss that question first. First question, capital A. Capital A is equal to, it is a matrix phi alpha 0 alpha phi alpha 0 0 5. This is your matrix A, and he has given A square determinant is equal to 25. Then what is modulus of alpha, right? It is not a determinant, it is a modulus, means what is a positive value for alpha. So if I take determinant for A, so we know that it is, right, it is a upper triangular matrix. If it is upper triangular matrix or lower triangular matrix, what is determinant is equal to product of the diagonals, or else if it is a diagonal matrix, so determinant equal to what? Product of the diagonals. So since it is upper triangular matrix, that is the diagonal elements below the diagonals are 0. So its determinant is equal to what? Product of the diagonals, that is determinant of A is equal to 5 pi is 25 alpha, right? So determinant of A equal to what? 25 alpha. But he has given for us determinant A square determinant is equal to what? 25. So A square determinant is same as determinant of A whole square is equal to 25. A square determinant is same as determinant of A whole square. What is determinant of A? 25 alpha. 25 alpha square is equal to 25. So 25 get cancel. One more 25 is left out here. 25 alpha square is equal to what? 1. Right? Then alpha square is equal to what? 1 by 25. 1 by 25. Then alpha is equal to what? Plus or minus 1 by 5. Because square if it takes it becomes square root. What is square root of 25? 5 it is. But he is asking modulus of alpha. Means it should be a positive. Implies, right? Implies modulus of alpha is equal to what? Plus 1 by 5. Which option it is? Your first option. Answer A is correct. Right? So this was for the first question. Now let us go for second question. Second question. Cos 2 theta equal to what? 0. Then what is the determinant is asking. So cos 2 theta equal to 0 means 0 I can write as cos of which angle is 0? Cos of 90 degree, right? Cos of 90 degree equal to what? 0. Cos 0 is equal to what? 1. So both the side cos I can compare the angle. 2 theta equal to what? Pi by 4. 2 theta is equal to, pi by 2 implies theta equal to what? Pi by 4. So cos 2 theta equal to what? 0. For which angle it gives 0? Pi by 4. So pi by 4 if you substitute here, 2 ones are 2 to the cos 90 equal to what? 0. So theta equal to what? Pi by 4. So theta equal to pi by 4. What is the value of determinant of 0, cos theta, sin theta, cos theta, sin theta, 0, sin theta, 0, cos theta, whole square. This value is asking if cos 2 theta equal to 0, what is the determinant value is asking. Already got theta equal to 5 4, we'll replace it. 0, cos theta, sin theta, cos theta, sin theta 0, sin theta 0, cos theta. We know this cos 5 by 4, 1 by root 2. Sin 5 4 is equal to what? 1 by root 2, right? So sin 45 degrees same as cos of 45 degrees. So replacing that value, it becomes 0, 1 by root 2. Cos 45 is what? 1 by root 2. Cos 45 or as sin 45 is equal to what? 1 by root 2. 1 by root 2. This also is 1 by root 2. Cos 45 1 by root 2. 1 by root 2 and 0. Sin 45 again 1 by root 2. 0 cos 45 also is what? 1 by root 2 square. It is right. Determine square. Cos of 45 same as sin 45, that is 1 by root 2. Now we'll find its determinant. We know how to find it in terms of order 3 cross 3. It is plus, minus, plus. Keep in the mind square is there, right? So let us find the determinant of order 3 cross 3. Determinant of that one. So first you can say 0 into any number, right? Plus 0 into any number is equal to what? 0 only. Minus 1 by root 2. Minus 1 by root 2. Suppressing its row, its column, right? Suppressing its row, its column, dot 1 by 2 minus 0 it is. 1 by root 2 1 by root 2 is what? 1 by 2 minus 0. 1 by 2 minus 0. Plus 1 by root 2 plus 1 by root 2, suppressing first row, last column. So 1 by root 2 is 0, 0. 0 minus 1 by 2. 0 minus 1 by 2. Its square it is, right? Its square. It is how much it is? Minus 1 by 2 root 2. This also minus 1 by 2 root 2 whole square, right? So this becomes what? Minus 2 by 2 root 2 whole square. So 2 get cancelled. It is minus 1 by root 2 square. What is 1 by root 2 square? Is what? 1 by 2. Right? So square of negative power even is what? Positive 1 square is 1. Root 2 square is what? 2 only. So value is what? 1 by 2. So this value is equal to what? 1 by 2. Which of it is? First option. Right? So it is your answer as what? A. So this was for the second question. Now let us go for third question. So what is that? Third question says third question. If omega is the imaginary cube root of unity, then the value of, right? What is the value of a determinant of 1 plus omega square minus omega 1 plus omega square omega minus omega square plus omega minus omega square. Right? What is the value asking? So determinant of this 3 cross 3 matrix. So we know the property in complex number. 1 omega square are called what? Cube root of unity. So those are the roots of a cubic equation, right? And 1 plus omega square is equal to what? 0. 1 plus omega square equal to 0. These are called what? 1 omega square are called what? Cube root of unity. And omega cube is equal to what? 1. Right? So when you find the roots for a cubic equation. 1 omega omega square of the roots for a cubic equation. So keeping these two results in the mind, let us apply some property or as operation and this evaluate this determinant. You can see if you add Cn plus C2, 1 plus omega square equal to what? 0 I can write. Again 1 plus omega plus omega square equal to what? 0. C1 plus C2 for 2 means these two terms becomes 0. Right? So in a determinant, if any two elements are 0 means it is easy to find the determinant value. So what should be our operation? C1 change to C1 plus C2. Here omega square plus omega plus omega is omega square plus 2 omega. But here 1 plus omega square plus omega is 0. 1 plus omega plus omega square equal to 0. So our operation is C1 change to C1 plus C2. You are doing operation on C1 only, right? Keeping C2 C3 as is. Keeping C2 C3 as is. Omega square omega omega minus omega square minus omega square, because you are doing operation only on C1. C1 change to C1 plus C2. C1 change to C1 plus C2. C2 and C3 keeping as is. When apply for this operation, so apply for how many elements? 3 elements. 1, 2, 3, because all they belongs to C1. When I apply for first element, 1 plus omega square equal to what? 0. So first element becomes 0. When I apply for second element, 1 plus omega square plus omega equal to what? 0. So second element becomes 0. Next here, omega square plus omega is equal to what? Omega square plus 2 omega. Omega square plus 2 omega. Now we can expand along C1, right? So your sign is what? Plus, minus, plus. It is A11, it is A21, minus, it is A31, plus. Right? So expanding along which C1. So plus 0 into a number is 0, minus 0 into a number is what? 0, not necessary. Plus omega square plus 2 omega into suppressing its row, right? Suppressing its row and its column. What is the product here? Omega square omega minus omega square. So suppressing its column, right? Minus omega square into omega square, minus omega raised to 4, minus omega raised to 4, minus omega into minus omega square, minus of minus, plus omega square, right? And omega cube, what is omega cube equal to what? 180. So omega raised to 4, I can attach omega cube into omega. What is omega cube value? 1. Right? So this will be, so first term keeping as this, omega square plus 2 omega into minus omega raised to 4, I'll attach omega cube into omega. What is omega cube? 1. So 1 into omega is what? Omega minus omega plus omega square. Now we'll simplify this term. So if we simplify, what we'll get? Omega square into minus omega plus omega square plus 2 omega into minus omega plus omega square. Omega square into omega minus omega cube plus omega raised to 4 minus 2 omega square plus 2 omega cube. Omega cube, what is omega cube? It is 1. So minus 1 plus again omega raised to 4 again as omega cube into omega. Omega cube equal to what? 1. 1 into omega minus 2 omega square plus omega cube is what? 1. 2 ones on, it is 2. Right? 2 minus 1 is equal to what? 1. 1 plus omega minus 2 omega square. So what is 1 plus omega? Right? What is 1 plus omega? Minus omega square. 1 plus omega square is 0. 1 plus omega equal to what? Minus omega square. So this result I'll use here. 1 plus omega is minus omega square minus 2 omega square is what? Minus 3 omega square. So this value is what? What is value? Minus 3 omega square. Keeping in mind this result, 1 plus omega square is 0. Omega cube equal to what? 1. So which option it is? Fourth option, right? That is your answer B. Right? So this was about the third question. Now let us go for fourth question. Fourth question. So if x, y, z are all different from zeros and determinant equal to 0. So determinant of 1 plus x, 1, 1, 1, 1 plus y, 1, 1, 1, 1 plus z is equal to 0, right? Determinant equal to 0. What is the value of x inverse plus y inverse plus z inverse, right? What is the value of x inverse plus y inverse plus z inverse? This type of example you have solved in theory, right? So this result is equal to, right? What is that result? X, y, z, right? It is that standard result. What is the result of 1 plus x, 1, 1, 1, 1 plus y, 1, 1, 1, 1 plus z, right? Is equal to all the non-diagonals are 1, 1, 1 and diagonals are 1 plus x, 1 plus y, 1 plus z. This result is equal to x, y, z into 1 plus 1 by x plus 1 by y plus 1 by z, right? So this result is equal to what? X, y, z into 1 plus 1 by x plus 1 by y plus 1 by z. But he has given us this value is equal to 0, right? Already this value is equal to 0. So this is 0. 0 equal to x, y, z, right? Into 1 plus 1 by x plus 1 by y plus 1 by z, right? So 0 by x, y, z equal to 0. Plus 1 if it takes it become minus 1. Minus 1 is equal to 1 by x, nothing but what? X power minus 1 plus y power minus 1 plus z power minus 1. So the value of, right, implies x power minus 1 plus y power minus 1 plus z power minus 1 is equal to what? Minus 1. So this value is equal to what? Minus 1. Which option it is? It is your fourth option. Answer D, right? It is your fourth option equal to minus 1. So this was about the fourth question. Now let us see fifth question. So what is the fifth question says? Fifth one. Fifth question. F of x equal to determinant of 0, x minus a, x minus b, x plus a, 0, x minus c, x plus b, x plus c, 0. Then then which option is correct, right? So first option he has given f of a equal to 0. Second option he has given f of b equal to 0. Third option he has given f of 0 equal to 0. And fourth option he has given f of 1 is equal to what? 0. So this type of example I think it was already yesterday's class, same type, right? So because what is the result here is saying? Determinant of a skew symmetric matrix of odd order, that is 3 cross 3, 5 cross 5, 7 cross 7 cross 7, 9 cross 9 equal to what? 0. Determinant of a skew symmetric matrix of odd order equal to what? 0. So if I take first option f of a, right, replacing x as what? A. So if I replace x as a, 0, a minus a 0, but in this a minus b I am getting, right? So any row or any column I am getting as 0. So first option fails, means this value is not equal to 0. Second option again, if we replace x by b, right? So again x by b minus a I am getting, right? So here it is 0, but 0 b minus a 0 I am getting. Again I cannot tell that this value is also not equal to 0. Second option also fails. But third option, if you can say replacing x as what? 0. So if I take x as 0, right? It is 0 minus a, right? Minus b, it is plus a, 0 minus c, b, C and 0, replacing x as what? 0. So you can say it is a skew symmetric matrix. The elements above the principal dimension and below the principal dimension are same, but with opposite sign. Opposite of plus A is minus A, opposite of plus B is minus B, opposite of plus C is minus C, and all the diagonal elements are 0. That indicates it's a skew symmetric matrix. So determinant of skew symmetric matrix is not 0. I can tell. So third option satisfies. So f of 0 equal to 0, and even fourth option also does not satisfy. So which option is correct? It's the third option, that is option number 3. F of 0 equal to 0. This was about the fifth question. Now let us go for sixth question. Sixth question. Which is related to what? Area of a triangle. So area of a triangle is 35. That is delta equal to 35. What is asking? Then what is the value? K. Right? So what is that formula? Delta equal to 1 by 2. 1 by 2 x1 y1 x2 y2 x3 y3, and one last one dot 1 1 1. This is the formula to find area of a triangle whose vertices are x1 y1 x2 y2 and x3 y3 by using determinant. Right? So let us replace delta is what? 35. 35 is equal to 1 by 2 x1 y1. It is 2 minus 6 5 4 k 4. Last is 1 1 1. Right? So 70. Right? 70 is equal to, right? So it is determinant of 2 minus 6 1 5 4 1 k 4 1. So let us find a determinant here. 70 is equal to here plus minus plus of 2 into suppressing first row first column. 4 ones are 4 minus 4 ones are 4 minus sign is minus, element is minus 6, suppressing first row second column. 1 into 5 5, right? 5 minus k into 1 k, 5 minus k, sign is plus, element is 1, suppressing first row third column. 4 5s are 20, 20 minus 4k, 20 minus 4k, right? So this is what determinant of the determinant of this matrix. Let us find the k value. I am keeping in mind whenever he has given the area and still to find the k value. It can be area can be positive or negative depending upon the what else you take. If you take in terms of anti-clockwise, right? If you take in terms of anti-clockwise, you get area is what? Positive. If you take in terms of clockwise, area get in terms of negative. So there are two values of k. It will be, that is area will be plus 35 or minus 35. That indicates always you should take both the values, that is plus or minus. Whenever he has given the area, he is to find the k value, both the values of area to take. So if you simplify, what will you get? Plus or minus 70. Plus or minus 70 is equal to 2 into 4 minus 4, this is 0 now. This is 0. It is plus 6 into 6 into 5 minus k plus 20 minus 4k, right? Plus or minus 70. 6 5s are 30 minus 6k plus 20 minus 4k, right? 30 plus 20 is 50. Plus or minus 70 is equal to 30 plus 20 is 50 minus 10k. That indicates 50 minus 10k is equal to 70, right? So 50 minus 70 is equal to plus 10k. It is minus 20 is equal to 10k. Then k is equal to what? Minus. This is one k value. And one more, it can be negative also. That is 50 minus 10k is equal to minus 70. So 50 minus 10 is equal to plus 70, or 50 minus 10 is equal to minus 70. So we want k. 50 plus 70 is equal to 10k. 120 is equal to 10k. Notice k is equal to 12. So there are two values of k. One is minus 12, sorry, minus 2 or 12 or is 12 comma minus 2. Which option it is? Fourth option, that is k equal to plus 12 or minus 2. Your answer is D, right? Answer is what? D. So this all should be very careful. You should take both plus or minus for finding the value of k. So this was about the sixth question. Now let us go for seventh question. Seventh one. F of x. Seventh one. F of x equal to determinant of 1x, this is 2x, x, 3x into x minus 1 it is, 3x into x minus 1, x into x minus 1 into x minus 2, x into x minus 1 into x minus 2, this is third row, this is x, and x into x minus 1. This was about the second column. Third column I write here. We'll draw this one. X into x minus 1, x into x minus 1 into x minus 2, x plus 1, x plus 1, x plus 1 into x, x plus 1 into x minus 1. What is asking? He is asking f of 200. Right? So this is your determinant of order 3 cross 3. So it is asking what is f of 200. X plus 1 into x minus 1. Right? So 1x plus 1, 2x x into x minus 1, x plus 1 into x, 3x into x minus 1, x into x minus 1, x minus 2, x plus 1 into x into x minus 1. Okay, let us apply some property and we'll simplify this determinant value. Before that, any common term you can see from any row or any column. First row, nothing is common. Second row, x is there, right? X is there in second row, taking x is common from R2. And third row, x into x minus 1, x into x minus 1, x into x minus 1. So taking x has come from R2 and x into x minus 1 has come from R3. Then our f of x will be taking x has come from R2 and x into x minus 1 has come from R3. So 1, I'm not taking any count from R1. So keeping as this 1x, x plus 1, that is nothing is come from R1. In R2 I taken x as common, it is 2, x minus 1 and it is x plus 1. Here it is 3, right? Here it is x minus 2 and it is x plus 1. Right? Again, what we can see as common, x plus 1 has come from C3. So first we have taken x has come from R2 and x into x minus 1 has come from R3. Now we will take x plus 1 is present in C3. Right? This is C1, C2, C3. So taking x plus 1 has come from C3. So x plus 1 if we take common, f of x equal to x square into x minus 1 into x plus 1. So it is 1, 2, 3, x minus 1, x minus 2, 1, 1, 1 is left out. Right? So we converted into simplest form by taking as a common. Now we can evaluate that determinant. Let us see if we evaluate the determinant, what will we get. Right? Again, anyway, applying any operation, whether you can convert it to simplest form. Let us see. Again, by applying any operation, whether you can convert it into simplest form. So we are already aware that in a determinant, if any row or any column is 1, 1, 1, we are making to it as 0. So if we make, or you can see here is C3, right? C3 is all 1, 1. So let us make this term as 0 and exponent of C3 will get the return value easily, right? So any row or any column consisting of 1, 1, 1, we are making to input as 0. So how to make 0? 1 minus 1 is 0, 1 minus 1 is 0. Means R2 change to, this is your R2. R2 minus R1, R3 change to R3 minus R1. So let us apply that operation. R2 change to, R2 minus R1 and R3 change to R3 minus R1. So this will give as this f of x is equal to x square into x minus 1 into x plus 1. So you are applying operation on R2 and R3. You are not applying any operation on R1. So let us keep R1 as it is. 1x 1. 1x 1. So when I apply for R2, 2 minus 1 is equal to 1. Right? X minus 1 minus x. X minus 1 minus x plus x cancel. Minus 1 is left out. Here 1 minus 1 0. So this is what R2 be changed. Now same operation applying for R3 also. What is that operation R3? R3 changes to R3 minus R1. R3 minus R1. 3 minus 1 is what? 2. Right? X minus 2 minus x. What is the third? Minus 2. Right? And next here 1 minus 1 equal to what? 0. Now let us expand along C3 because two elements are 0 here. Their sign is plus minus plus. F of x is x square into x minus 1 into x plus 1. It is plus 1 into suppressing its row, its column. Minus 2 into 1 is what? Minus 2. Minus 2 into minus 1. Minus 2 minus of 1 is plus 2. Right? Minus 0 into number is 0. Plus 0 into number is what? 0. What is minus 2 plus 1? So it is minus 2 plus 2? 0. Again, total term is what? 0 only. 0 into a number equal to what? 0 only. So f of 0, this is what? 0. So f of x is what? 0. Right? So total, this function f of x is defined as determinant of, right? So determinant of 3 cross matrix, rating as 0. If f of x is 0, then what is f of 200? It is also is 0 because it's a constant function. So implies f of 200 is also equal to 0. So which option is correct? It's the first option. Answer is what? A. Right? So this was about the 7th question. Now let us go for 8th question. 8th question. Eighth or the question says, if x equal to, right, 8th solution, x equal to minus 4 is one of the root of the determinant delta equal to x2 3, 1x1, 3 to x equal to 0. Find the other two roots. So x equal to minus 1 is one of the root for this determinant. Means if you expand the determinant, I am getting cubic equation. Cubic equations are 3 roots I will be getting. In that 3 roots, already has been one of the roots is what? Minus 4. So you have to find another 2 roots. Which are the another 2 roots? Means what are the other 2 values of x you have to find. So if I take this determinant, so we can say here, right? So if you go for R1 change to R1 plus R2 plus R3. X plus 4 is also x plus 4, x plus 4. So in the determinant, what is the first property you are applying for determinant? R1 change to Rn plus R2 plus R3 or C1 change to Cn plus C2 plus C3. If I add all the 3 rows or 3 columns, if any common term I am getting, that will take it as an outside. Here you can see here, if I apply R1 change to Rn plus R2 plus R3, that is x plus 4, x plus 4, x plus 4. And if I apply for C1 change to Cn plus C2 plus C3, C1 x plus 5, here it is x plus 2, I am not getting same term. Here it is 5 plus x something, so I am not getting common term when I apply for C1 change to Cn plus C2 plus C3. But I am getting something common, x plus 4 is common when I apply R1 change to Rn plus R2 plus R3. So let us apply that property. R1 change to R1 plus R2 plus R3. They are applying on R1. So let us keep R2 and R3 as it is 1x 1 3 to x, right? Because you are not applying any property on, sorry, this operation you are not applying operation on R2 and R3 only on R1. So this operation should apply for how many elements? 3 elements, x, 2, 3, because all these belongs to R1. What is corresponding R2 for x? 1. What is corresponding R3 for x? 3. R1 change to Rn plus R2 plus R3, x plus 4. Right? It is x plus 4. Here also, what is R2? X. What is R3? 2. 2 plus x plus 2. It is x plus 4. X plus 4. Again, for this, what is R2? 1. What is R3? X. R1 change to Rn plus R2 plus R3. 3 plus 1 is what? 4. 4 plus x or x plus 4. So taking x plus 4 as common. X plus 4 as common means what is left out here? 1, 1, 1, 1x, 1, 3, 2, x equal to 0. And we know that in a determinant, if any row or any column is on above 1, 1, 1, we are making 2 element as 0. So let us make 2 element as 0. So if I make 2 elements, which are 2 elements 0 and make C2 and C3, it means C2 minus C1, C3 minus C1. So C2 change to C2 minus C1 and C3 change to C3 minus C1. X plus 4. X plus 4 keeping as it is, they are applying for which column? C2 and C3. So keep C1 as it is. It is 113, right? 1 they are applying for C2 and C3. C2 change to C2 minus C1, C3 change to C3 minus C1. 1 minus 1 you got 0. It is x minus 1. It is minus 1. Next 1 minus 1 is 0. 1 minus 1 is 0. X minus 3. Right? So again we know that it is what type of matrix? Elements above the principal diagonals are 0, right? If the elements above the principal diagonals are 0 means what type of matrix it is? Lower triangle matrix. If it is upper triangle matrix or lower triangle matrix, what is determinant value equal to? Product of the diagonals. 1 into x minus 1 into x minus 3 is the determinant value for this one, which is equal to this is 0, right? So x plus 4 into x minus 1 into x minus 3 equal to what? 0. Already as given, minus 4 is one of the root, right? Then what are another root? Another two roots, 1 and 3. So x equal to 1 and 1 more is what? X equal to what? 3. So which option it is? It is a first option, right? That is answer is what? A. X equal to minus 4, 1 and 3. Right? Already we know x equal to minus 4 is one root already as given here, right? So x equal to 1 and x equal to 3 are the another two roots. So this was about the 8th question. Now let us see 9th question. What are the factors it is asking? Factors. Ninth one, factors of 1, 1, 1, x, y, 1, x square, y square, 1, right? So what is the factors is asking, and we know that already told in a determinant if any row, any column is what? 1, 1, 1, we are making 2 element as 0. Here it is what which column is 1, 1, 1? C3, this is C1, C2, C3. So this is C3 is what? 1, 1, 1. Let us make each element as 1, 1, 1. How to make therefore this element only? R2, this comes in R2, right? So R2 minus R1, R3 minus R1. So that each term becomes 0. So your operations are R2 change to R2 change to, right? Or else you can make these terms are also 0, right? that is C2 minus C1 and C3 minus C1. So let us make these terms as what? 0 only, right? So C2 change to C2 minus C1 or C3 change to C3 minus C1 or R2 minus R1 and R3 minus R1. So if I apply C2 change to C2 minus C1 and C3 change to C3 minus C1. So C1 keeping as it is 1x x square, it is 1 minus 1 is 0, y minus x C2 minus C1, y square minus x square you can write as what? Y plus x into y minus x. 1 minus 1 is 0, it is 1 minus x, it is 1 minus x square, right? One minus x it is. Y minus x, y square minus x square is what? Y plus x into y minus x. 1 minus 1 is 0. 1 minus x, and this 1 minus x square we can write as 1 plus x into 1 minus x. Right? What is common you can observe here? C1 that is common. C2 what is common? Y minus x is common. Y minus x. And C3 is what? 1 minus x is common. So taking y minus x is common from C2 and taking 1 minus x is common from C3. So if I take y minus x is common from C2 and 1 minus x is common from C3, what is left out? 1 0 0, right? X, y minus x I take common 1 x square y plus x. Here y 1 minus x are taken common, 1 plus x is left out. So let us expand along R1. Here is plus, minus, plus, right? So if you expand along R1, what will you get? Expanding along R1. Y minus x into 1 minus x. Right? Minus 0 number plus 0 number is 0. So suppressing first row, first column. Right? So 1 into it is 1 into 1 plus x is 1 plus x minus 1 into y plus x means minus x minus y minus x minus x minus y minus x and minus y. So minus 0 into number is 0 plus 0 into number is what? 0. Minus x plus x get cancelled. Right? So what is the code? Y minus x into 1 minus x into 1 minus y. So you can see 1 minus 1 y minus x is there, but 1 minus x and 1 x minus 1 and y minus 1 is there. So if I take minus is common, y minus x into, here if I take minus is common, it is x minus 1. Here also minus is common, y minus 1. Right? So here I take a minus common, here also minus common. 1 minus x I can minus, minus of x minus 1. 1 minus of y I can plus minus of y minus of minus plus. So these are the factors I am getting. So which alternative it is? Y minus x, x minus 1, y minus 1 is the first option. Right? So I can tell that is answer A. So the ninth one, right? So ninth one is what? First option is correct. These are the factors for that determinant of given determinant of matrix of order 3 cross 3. So this was a ninth question. Let us discuss the 10th question. So what is that 10th question says? It is related to finding A inverse. A inverse of matrix 3 cross 3. Tenth one, capital A. Capital A is equal to cos x sin x 0 minus sin x cos x 0 0 0 1. What are you asking? A inverse. So if it is of 2 cross 2, easily you can find A inverse. But it is of order 3 cross 3. So let us find A inverse. Before that, determinant of A. So determinant of A means let us expand along C3. What are the sign here? Plus, minus, plus. You can find determinant along any row or any column. Plus 0 to number 0, minus 0 to number 0, plus 1 into suppressing its row, its column. Cos x into cos x, cos square x, minus. Minus sin x into sin x dot, plus sin square x, right? So cos square x plus sin square x, multiplication principal minus multiplication secondary elements. So cos square x plus sin square x equal to what? 1 it is. Cos square x plus sin square x equal to what? 1. So determinant of A is equal to what? 1. So now let us find adjoint of A, or as cofactor of each element, A11, A12, A13. So if you are finding A11 plus suppressing its row is column, cos x into 1 is what? Cos x minus 0. It is cos x. A12 minus suppressing first row, second column. 1 into minus sin x, it is, right? So it is minus sin x, minus of minus, plus sin x. It is cos x, because A12 is suppressing first row, second column. 1 into minus sin x dot minus sin x minus 0. A13 plus suppressing first row, third column. 0 into sin x 0, minus 0 into cos x are 0. So this is 0. A21 minus A2 is what? Second row, first column to suppress. 1 into sin x minus 0. Right? Sin x minus 0, it is sin x. A22 plus A22 means second row, second column to suppress. Second row, second column to suppress is what? 1 into cos x dot cos x. Second row, second column. 1 into cos x minus 0. Cos x minus 0 is what? Cos x. A23 minus 23 is what? Second row, third column. Second row, third column to suppress 1. 0 into cos x 0, 0 into sin x dot 0. 0 minus 0 equal to what? 0. So A23 we got. Next A31. A31, A32, A33. A31 plus of, right? Third row, first column to suppress. Third row, first column. 0 minus 0 is what? 0. Right? It is 0. A32, third row, second column to suppress. Third row, second column, 0 minus 0 is what? 0. A33 plus of third row, third column to suppress. Cos x into cos x, cos square x plus sin square x, it is what? 1. It is 1 and everything. So let us write adjoint of A now. So we will write direct elements in column order. Right? If you write in column order, that is the transpose of adjoint, transpose of cofactor matrix. It is 1 cos x sin x cos x 0 x dot 0 0 1. So A inverse is 1 by determinant of A. What is determinant of A? Determinant of A is equal to what? Plus 1 only, right? A12 is what? Minus suppressing cos x sin x 0 minus sin x 0 cos x 0 0 0 cos x it is, right? So it is I'm writing in terms of A is cos x sin x 0 minus sin x 0 0 0 0 1. So adjoint of A is what? 1 by determinant of into adjoint of A 1 cos x sin x, right? Sin x cos x 0 0 0 1 are written in terms of column. So what is the f of x equal to? Whether it is f of minus x, it is cos of minus x is cos x only. Somewhere mistake. Okay, let us check. Cos x sin x 0 minus sin x cos x 0 0 0 1. A11 suppressing first row, right? First row, first column. 1 into cos x minus 0 is cos x, right? So determinant of A. Okay, I have written 1 starting, no? Right. A1 is cos x, no? It is A11 is cos x. Cos x. A12 is sin x. Right? A13 is 0. A21 is what? Sin x. A to 1, second row, first column, second row, first column is of this 1 into sin x, minus 0 is what? Minus sin x, right? Sin x minus 0 is what? Minus sin x. Minus sin x. It is cos x and 0. Last is 0, 0, 1. This is your adjoint of A. So A inverse is 1 by determinant of A. What is determinant of A is what? 1 into adjoint of A. It is cos x minus sin x 0, sin x cos x 0, 0, 0, 1. So this is nothing but what? It's your, this is equal to f of x as again, right? This is equal to f of x. So if I replace x by minus x, cos of minus x is cos x, sin of minus x is minus sin x. This is 0, this is also 0. Sin of minus x is what? Minus sin x, minus of minus, plus sin x. Cos of minus x is cos x. This is 0 and 0, 0, 1, 0, 0, 1. That indicates its inverse is nothing but what? F of minus x. So if f of x equal to this matrix, and A inverse is what? F of minus x. So what is f of minus x? I think that is your A inverse. So this was about the 10th question. So which option is correct? It's the first option. Answer A is correct. So this was the 10th question. 11th question. So 11th question is a thing, right? What is the 11th question says? Which of the following is correct? First option, determinant is a square matrix. Whether determinant is a square matrix? No. First option fails. Second option, determinant is a number associated to a matrix. No, it is a number associated to square matrix. Second option also failed. Third option, determinant is a number associated to a square matrix. That's third option is correct. So your answer is what? C for the 11th question, right? And even 12th question. 12th question is also easy, right? What is asking? If capital A is a scalar and A is any square n square matrix, then what is determinant of K into A? What is determinant of K into A? K raised to n into determinant of A. Which option it is? Fourth option, right? That is option number D. So this was about the 12th question. Now let us discuss 13th question. 13th question, which is related to trigonometric formula. 13th question. Thirteenth one. The value of delta, where delta is given by cos square theta, cos square theta 1, cos square theta, cos square theta and minus 1, 42, 40 and 2. So what is the value for this determinant asking? So we'll use the result, that is 1 plus, what is 1 plus cos square theta equal to cos square theta, 1 plus tan square equal to secant square, 1 plus cos square equal to cos square, and sin square x plus cos square x equal to 1. So 1 plus cos square equal to cos square. Then what is cos square equal to cos square equal to cos square theta minus 1. So if I apply C1 change to, right? C1 change to C1 minus C2 minus C3. C1 minus C2. What is cos square minus cos square? Cos square minus cos square is what? 1. 1 minus 1 equal to what? 0. So this becomes what? 0. This becomes first element becomes what? 0. If I apply, that is C1. C1 change to C1 minus C2 minus C3. If I apply C1 change to C1 minus C2 minus C3. For the first element, if I apply this operation, it will apply for how many elements? 3 elements. Cos square theta, cos square theta, and 42, because all are belongs to C1. When I apply for first element, C1 minus C2 minus C3. What is cos square? Right? Cos square theta minus cos square theta minus 1. What is cos square minus cos square is what? 1. 1 minus 1 equal to 0. So this element becomes 0. right? Now let us apply for second element. This also comes to C1, right? C1 is to C1 minus C2 minus C3 means cos square theta minus cosec square theta minus of minus plus 1. C1 minus C2 minus C3 minus of minus plus 1. What is cos square minus cosec square? Right? Cos square minus cosec square is equal to minus 1. Right? So it is minus 1 plus 1 is equal to again 0. So this element also becomes 0. Next C1. C1 changes to C1 minus C2 minus C3. 42 minus 40 is what? 2. 2 minus equal to 0. So this also becomes what? 0. So your delta value, first column becomes what? 0, 0, 0. Your second column has this cos square theta, cosec square theta, and 40. This is 1 minus 1, 2. Correct now? So we have a property, we determine if any row or any column is made up of 0, 0, 0, then it's what is value equal to 0. Right? So here C1, right? C1 is 0, so total value is equal to 0. So which option it is correct? It's your option number 3. Right? Answer is what? C. C option is correct. So this was about the 13th question. Now let us see 14th question. What is that 14th question says? 14th question. Fourteenth one. What you are asking? If A is a matrix about 3 cross 3, then what is A square inverse? Right? What is A square inverse? So this A square we can write as A into A inverse, right? So what is AB inverse is given by B inverse into A inverse. Correct? No? AB inverse into A inverse. So this is AB inverse is what? B inverse into A inverse. That is A inverse whole square. So A square its inverse of A inverse whole square. So because AB inverse is the form AB inverse or B inverse into A inverse into A inverse is or A inverse A whole square. So which option is correct? It's the first option, right? Answer is what? A. This was for 14th question. So let us see 15th question. What is that? 15th question says if A is a matrix of order 3 cross 3. A is a matrix of order 3 cross 3 is what? Capital A is what? A11, A12, A13, A21, A22, A23, A31, A32, and A33. Capital A is a matrix of order 3 cross 3. Then the number of minors, right? How many minors it has? Since capital is a matrix of order 3 cross 3, how many elements it has? 9 elements. So that indicates 9 minor will be getting. So number of minor is what? 9. Number of minor in determinant, right? Is what? 9. So which option it is? Fourth option. That is D. Since it is a 3 cross 3 matrix, there are 9 elements in that one. So in its determinant also there are 9 minors, right? So number of minors, that is 15 to 1. Fourth option is correct. Now let us go for 16th question. So 16th question. What that 16th question says? One. So x cube plus px plus q is equal to 0. Alpha, beta, gamma are the rules for the cubic equation, right? What are rules for the cubic equation? Then what is the value of that determinant? So we know that if it is quadratic equation, ax square plus bx plus c equal to 0, right? If alpha and beta are the two roots, what is sum of the roots is given by minus p by a. What is product of the roots is given by c by a, right? Sum of the root of alpha and beta are the two roots. Sum of the roots is given by minus b by a. Product of the roots is given by c by a. If it is cubic equation, ax cube plus bx square plus cx plus d equal to 0. Means what are the roots here? Alpha, beta, gamma. Three roots are there. Right? So sum of the roots alpha plus beta plus gamma. Sum of the roots is given by minus b by a. Product of two roots alpha beta, beta gamma plus gamma alpha is equal to what? C by a. This is what product sum of the roots and product of the roots. But there are three roots. So sum of the three roots and product of two roots, and one more is what? Product of three roots is what? Minus c by a. Right? So this is a cubic equation. Alpha, beta, gamma with root three roots. Alpha plus beta plus gamma is minus b by a. B is not coefficient of x square. The coefficient of x square is not there. A is not coefficient of x cube. B is coefficient of x square. C is coefficient of x, and D is a constant term. But here coefficient of x square is not there. That indicates coefficient of x square is what? 0. So minus 0 by a is not 1. It is not 0. Right? So this you should remember. Sum of the roots and sum of the product of two roots and product of three roots is minus b by a if it is a cubic equation. So since it is a cubic equation, the sum of the roots is not 0. I am getting. And what is sum of product of two roots? Alpha beta plus beta gamma plus gamma alpha is what? C by a. C is what? P by 1. It is what? P. And product of the three roots is what? Minus c by a minus q by 1, it is minus q. So it is asking what is the determinant value. So what is the determinant value of alpha, beta, gamma, beta, gamma, alpha, gamma, alpha, beta. Right? So what is this determinant is asking. So again, what is our first operation we are trying? R1 change to Rn plus R2 plus R3, or C1 change to Cn plus C2 plus C3. Any common term I'm getting. Let us check. So if I apply R1 change to Rn plus R2 plus R3, alpha plus beta plus gamma. Again, this also is R1. This is R1. Again, beta plus gamma plus alpha. That is alpha plus beta plus gamma. Again, gamma plus alpha plus beta. Again, alpha plus beta plus gamma. Means if I apply R1 change to R1 plus R2 plus R3, I am getting alpha plus beta plus gamma as common. And even I can go for C1. C1 change to Cn plus C2 plus C3. Right? C1 change to Cn plus C2 plus C3. For this element, C1 change to Cn plus C2 plus C3. Let us apply R1. R1 change to R1 plus R2 plus R3. Means keeping R2 and R3 as is. Right? Beta, gamma, alpha, gamma, alpha, beta. So for the first element, if I apply R1, right? R1 change to R1 plus R2 plus R3. What is corresponding R2 for alpha, beta? What is corresponding R3 for alpha, gamma? R1 change to Rn plus R2 plus R3, alpha plus beta plus gamma. Here I am getting as alpha plus beta plus gamma. Here also, for this element is over. Now second element. What is second element? B. R1 change to Rn plus R2 plus R3. What is corresponding R2 for beta, gamma? What is corresponding R3 for beta, gamma? Beta plus gamma plus alpha is what? Again alpha plus beta plus gamma. So here I am getting alpha plus beta plus gamma as common. Again, for this element if I apply it, because this also is R1. For these three elements I should apply this operation, because I written R1 change to Rn plus R2 plus R3. R2 and R3 kept as is. For this element if I apply, what is R2? Alpha. What is R3? Beta. Alpha plus beta plus gamma. Again, then I am getting as alpha plus beta plus gamma. If I take common, here this is 1 is left out. Right? So common, what is the common I am getting here? Alpha plus beta plus gamma. Right? This is a common I am getting in first row. But what is this value? Alpha plus beta plus gamma is what? 0. So this total term is what? 0. 0 into any determinant is equal to 0 only. So total value is equal to 0. So this return value is equal to 0. Which option it is? Second option. Answer B. Right? So what we applied here? Sum of the roots, sum of product of two roots and product of three roots. And operation R1 change to Rn plus R2 plus R3. Alpha plus beta plus gamma getting common. This is 0. 0 at any determinant is equal to 0. So total answer is what? 0. So this was about the 16th question. Now let us see 17th question. What is that? 17th question says. Seventeenth question. What is adjoint of A inverse, right? So those 2 points, adjoint of A whole dash is same as adjoint of A dash, and adjoint of A whole inverse is same as adjoint of A inverse. So this I can enter the two standard results. So adjoint of A whole inverse is what? Adjoint of A inverse. So which option it is? It's the first option. And even if I take any one matrix for just checking purpose, if I take 2 close to matrix, adjoint of A whole inverse is equal to adjoint of A inverse. So which that option? It is first option, that is A. Adjoint of A whole inverse is same as adjoint of A inverse, and even adjoint of A whole dash is adjoint of A dash. 17. 18th question. So what is the determinant is asking? 1x y, 1x plus y, y, 1x x plus y. Right. So again, what is this determinant? Again, you can see in C1 there are 3 elements 1 1 1. Let us make these two elements as 0. How to make this as 0? R2 minus R1, R3 minus R1. So if I apply R2 change to R2 minus R1 and R3 change to R3 minus R1. So when I apply R2 and R3, keeping R1 as this, determinant of what is R1? 1x y. 1 minus 1 is equal to 0. X plus y minus x dot y is left out. Right? Y minus y 0. Again 1 minus 1 0. Again R3 minus R1. 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 X minus x 0. X plus y minus y. Minus y plus y cancel. X is left out. Right? Again, what type of matrix it is? Upper triangle matrix. Elements below the diagonals are 0. That is called upper triangle matrix. Elements above the diagonals are 0. That is called lower triangle matrix. So if it is upper triangle matrix or lower triangle matrix, determinant is equal to product of the diagonals. 1 into y into x dot xy. So its value is equal to xy. Which option it is? Second option. Answer B. Right? Okay, let us go for 18th question. What is that? 18th question says there are two statements in that 18th question. Right? Statement 1 is what? A inverse is 1 by 7 into 5i minus a, and statement 2, the polynomial a cube minus 2a square minus 3a plus I can be reduced in the form of 5 into a minus 4i. So let us take that what is the given condition is given. 19th question. 19th solution. So it is given here a square minus 5a plus 7i equal to 0. Right? So statement 1 is what? A inverse is given by statement 1. A inverse is equal to 1 by 7 into 5i minus a. And statement 2, the polynomial a cube minus 2a square minus 3a plus I can be reduced in the form of 5 into a minus 4i. Okay, let us see. This is the given condition for us. This is statement 1. A inverse is given by this one, and statement 2, this can be reduced in this form. So let us see whether both the statements are correct or not, or only one statement is correct or both the statements are correct. So a square a square minus 5a plus 7I equal to 0. So a square I can write as a into a minus 5a plus 7I equal to 0. Same pre-multiplication by a inverse on both sides. 5 into a inverse into a plus 7 into a inverse into I equal to 0. A star b star c, a star b star c. And what is a inverse into a is I. 7 a inverse into I, a inverse equal to 0. What is a inverse into a is what? I into a is what? A only. A minus 5I plus 7a inverse equal to 0. Or else a inverse is equal to 1 by 7 into 5I minus a na. A inverse is what? 1 by 7 into 5I minus a. Means statement 1 is correct, right? So let us check now statement 2. So statement 1 what is given? A from this equation, A inverse is given by this one. Yes, 1 by 7 into 5 minus A. So statement 1 is correct. So let us see whether statement 2 is correct or not. Right? So statement 2, A cube. Okay. A cube minus statement you take a cube minus 2a square minus 3a plus I. What is a cube? We'll find a square from this one. So a square from first equation. What is a square equal to? A square equal to what? Plus 5a minus 7i. Right? A square minus 5 plus 7 equal to 0. A square equal to plus 5 minus 7. That is our a square. We'll find a cube also. Right? So this is a square. A cube is what? Multiply a both side. Right? A into 5i minus 7i. 5i minus 7i. A into a square is what? A cube is equal to what? 5a square minus 7ai. Right? So a cube value is equal to what? 5a square minus 7a into is what? A only, right? So taking the value of a cube and a square and substituting this equation, let us see what we'll get with that. This value is equal to what? 5 into a minus 4i. A cube. What is a cube? 5 into a square minus 7a minus 2 into what is a square? A square is what? 5a minus 7i. Minus 3a plus I, right? So 5a cube, what is a cube? 5 square minus 7, a cube is of 5 square minus 7a, right? This is a cube. A cube is of 5 square minus 7a minus 2, a square is of 5a minus 7i minus 3a plus I as this. Okay, again I can replace this a square value. What is a square? 5a minus 7i. 5 into a square minus 7a, right? Minus 7a will multiply inside. 5 2s are 10a, 7 2s are 14i minus 3a plus I. Again multiply inside. 5 5s are 25a, 5 7s are 35i minus 7a minus 10a minus 14i minus 3a plus I. We'll add a plus 25, right? That was 15. 15 minus 25 minus 30. Okay. It is minus 20 now. Minus 10 minus 7 minus 17. Minus 10 minus result minus 17 minus result minus 20. Minus 20 plus 25 is what? 5a, right? 35i, it is 34, right? 30 minus 35 plus 1 is what? 34. 34 minus 14 is what? 0, 20, right? Minus 20i. What is common? 5 is common. 5 4s are 5 into a minus 5 4s are 20. So that indicates, right? Statement without this can be written in the form of 5 into a minus 4i. So statement 2 is also is not correct. So that indicates 19th one. Which option is correct? First option, both statement 1 and statement 2 both are correct. That is your answer A. That is our first option. Okay, let us discuss last question, 20th one. 20th one. So what is 20th one? If A is a 3x matrix such that determinant of phi into adjoint of A is equal to 5. What are you asking? What is determinant of A is equal to? Determinant of phi into adjoint of A is equal to 5. What is determinant of A? So we know that determinant of K into A. Then what is determinant of K into A? K raised to determinant of A. K raised to n. What is n here? 3 cross matrix. 5 4 3 into determinant of adjoint of A is equal to 5. So 5 4 3 what is left out here? 5 4 2 into determinant of adjoint of A is equal to 1. But what is determinant of adjoint of A? Determinant of A is to n minus 1. 5 squares are 25. Determinant of adjoint of A is determinant of A is to n minus 1. What is n is equal to? 3 is a matrix of order 3 cross 3 minus 2 is equal to 1. So determinant of A equals is equal to 1 by 25. So determinant of A is equal to plus or minus 1 by 5. Again, don't take as what modulus, right? It is not modulus, it is a determinant. In the first example or second example, what we did first example, I think, right? That was modulus of alpha. But this is determinant of a matrix. It is that was a constant. It is a modulus, but it is a matrix. It is not modulus. It is a determinant value. That is value of the square matrix. Determinant of A equal to plus or minus 1. So which option is correct? Is your first option is correct, right? So this was some question which will help you for your weekly test. So remaining 5 questions are easy. Those you can solve it by yourself, right? So okay, tomorrow they will be starting a new chapter, that is inverse trigonometry function. Okay, so this chapter concludes here. Okay, thank you, students.